Hello, Heron students. Today you will be taking the notes. Make sure that you grab out the packet that you should have picked up in class on Tuesday. If you were absent, of course, you can find extra copies in the bin in the back of the room. We're going to start with 11.1, which is all about the first law of thermodynamics. So what is thermodynamics? It is the process of energy transfer. And the energy that is transferred is called heat. Heat will always transfer from hot surfaces to surfaces lacking heat. And if you remember back to when we first talked about temperature, we used the thermometer reader and saw that several surfaces were approximately the same temperature, but they felt like they were very different temperatures because what we felt was the energy transfer and energy moving from your hot or warm hand to, say, the metal on a chair, and you felt that heat transfer. When two objects reach the same temperature, they are said to be at thermal equilibrium. Pause the video and answer the question, are heat and temperature the same thing? No, they are not the same thing. Make sure you have an explanation stating that, and we can talk more about that next week. So thermodynamics. Our first law of thermodynamics is that heat is conserved. Energy cannot be created nor destroyed. This is something you've been learning for a really long time because instead, if it's conserved, it can still transfer. It always transfers from one thing to another form. The second law of thermodynamics states that energy tends to disperse. The universe is in an increasing state of disorder. For example, houses will eventually fall down. You see this with sandcastles. They're slowly going to crumble away as the energy disperses. Energy is absorbed by a substance as it warms up, melts, or boils. So again, energy is absorbed, which causes things to warm up. And then, of course, the opposite is true. Energy is released when the substance cools down, condenses, or freezes. So if you put something in a freezer, think about it. Is energy being released or is energy being absorbed? If you put cookies in the oven, is energy being absorbed or is it being released? This idea is of heat transfer. It's just being transferred from one form to another, from the hot oven to your cookies, for example. Systems and surroundings. It is important for us to distinguish between the system and the surroundings. We see this picture on the right side of your screen as well. The system is the process you're focusing on. What are we studying right now? So if we're thinking about, we might be sitting by a campfire getting warm, the system would be the campfire, and the surroundings would be the dirt around the campfire, the marshmallow roasting, the people sitting around it. Or if we're thinking about a water in a beaker, we might be, the system might be the water in the beaker, and the surrounding is everything else. The hot plate it's sitting on to heat up, the countertop it's sitting on, the stirring rod, any of those sorts of things. And then, of course, the surrounding, we just said, is everything outside of the system, which is pretty much what I just said. Here's another picture. If we were studying the liquid inside the Erlenmeyer flask, we would say the system was the Erlenmeyer flask. The surrounding is everything around that Erlenmeyer flask, which in the next picture is everything in the blue. And then, of course, the universe makes up all of the system and surroundings that we can study. We are going to pause there. If you need to review